Kip Stephen Thorne, is an American theoretical physicist, known for his contributions in gravitational physics and astrophysics. A longtime friend and colleague of Stephen Hawking and Carl Sagan. He was the Feynman Professor of Theoretical Physics at the California Institute of Technology until 2009 and is one of the world's leading experts on the astrophysical implications of Einstein's general theory of relativity. He continues to do scientific research and acted as a scientific consultant in the science fiction film Interstellar. Life and career. Thorne was born in Logan, Utah on June 1, 1940, the son of Utah State University professors D. Win Thorne and Allison Thorne, a soil chemist and an economist, respectively. Raised in an academic environment, two of his four siblings also became professors. Thorne's parents were members of The Church of Jesus Christ of Latter-day Saints and raised Thorne in the LDS faith, though he now describes himself as atheist. Regarding his views on science and religion, Thorne has stated, "There are large numbers of my finest colleagues who are quite devout and believe in God. There is no fundamental incompatibility between science and religion. I happen to not believe in God." Thorne rapidly excelled at academics early in life, becoming one of the youngest full professors in the history of the California Institute of Technology. He received his B.S. degree from Caltech in 1962, and Ph.D. degree from Princeton University in 1965. He wrote his doctoral thesis, Geometrodynamics of Cylindrical Systems, under the supervision of relativist John Wheeler. Thorne returned to Caltech as an associate professor in 1967 and became a professor of theoretical physics in 1970, the William R. Keenan, Jr. Professor in 1981, and the Feynman Professor of Theoretical Physics in 1991. In June 2009 he resigned his Feynman professorship to pursue a career of writing and movie making. His first film project was Interstellar, working with Christopher Nolan. Throughout the years, Thorne has served as a mentor and thesis advisor for many leading theorists who now work on observational, experimental, or astrophysical aspects of general relativity. Approximately 50 physicists have received PhDs at Caltech under Thorne's personal mentorship. Thorne is known for his ability to convey the excitement and significance of discoveries in gravitation and astrophysics to both professional and lay audiences. In 1999, Thorne made some speculations on what the 21st century will find as the answers to the following questions. Is there a dark side of the universe populated by objects such as black holes? Can we observe the birth of the universe and its dark side using radiation made from space-time warp-age, or so-called gravitational waves? Will 21st century technology reveal quantum behavior in the realm of human-size objects? His presentations on subjects such as black holes, gravitational radiation, relativity, time travel, and wormholes have been included in PBS shows in the US, and in the United Kingdom on the BBC. Thorne and Linda Jean Peterson married in 1960. Their children are Kara San and Brett Carter, an architect. Thorne and Peterson divorced in 1977. Thorne and his second wife, Carolee Joyce Winstein, a professor of biokinesiology and physical therapy at USC, married in 1984. Research. Thorne's research has principally focused on relativistic astrophysics and gravitation physics, with emphasis on relativistic stars, black holes and especially gravitational waves. He is perhaps best known to the public for his controversial theory that wormholes can conceivably be used for time travel. However, Thorne's scientific contributions, which center on the general nature of space, time, and gravity, span the full range of topics in general relativity, gravitational waves and LIGO. Thorne's work has dealt with the prediction of gravity wave strengths and their temporal signatures as observed on Earth. These signatures are of great relevance to LIGO, a multi-institution gravity wave experiment for which Thorne has been a leading proponent. In 1984, he co-founded the LIGO project to discern and measure any fluctuations between two or more static points. Such fluctuations would be evidence of gravitational waves, as calculations describe. A significant aspect of his research is developing the mathematics necessary to analyze these objects. Thorne also carries out engineering design analyses for features of the LIGO that cannot be developed on the basis of experiment, and he gives advice on data analysis algorithms by which the waves will be sought. He has provided theoretical support for LIGO, including identifying gravitational wave sources that LIGO should target, designing the baffles to control scattered light in the LIGO beam tubes, and, in collaboration with Vladimir Brajinsky's research group, inventing quantum non-demolition designs for advanced gravity wave detectors and ways to reduce the most serious kind of noise in advanced detectors, thermoelastic noise. With Carlton M. Caves, Thorne invented the back-action evasion approach to quantum non-demolition measurements of the quadrature amplitudes of harmonic oscillators, a technique applicable both in gravitational wave detection and quantum optics. Black hole cosmology. Thorne has made contributions to black hole cosmology. Thorne proposed his hoop conjecture that cast aside the thought of a naked singularity. The hoop conjecture describes an imploding star turning into a black hole when the critical circumference of the designed hoop can be placed around it and set into rotation. That is, any object of mass m around which a hoop of circumference can be spun must be a black hole. As a tool to be used in both enterprises, astrophysics and theoretical physics, Thorne has developed an unusual approach, called the membrane paradigm, to the theory of black holes, and used it to clarify the Blandford's and eject mechanism by which black holes may power some quasars and active galactic nuclei. Thorne has investigated the quantum statistical mechanical origin of the entropy of a black hole and the entropy of a cosmological horizon in an inflationary model of the universe. With Wojciech he showed that the entropy of a black hole of known mass, angular momentum, and electric charge is the logarithm of the number of ways that the hole could have been made. With Igor Novikov and Don Page he developed the general relativistic theory of thin accretion disks around black holes, and using this theory he deduced that with a doubling of its mass by such accretion a black hole will be spun up to 0.998 of the maximum spin allowed by general relativity, but not any farther. This is probably the maximum black hole spin allowed in nature. He, along with his mentor John Wheeler, additionally proved that it was impossible for cylindrical magnetic field lines to implode. Both Hawking and Thorne have theorized that a singularity exists in the interior of a black hole. Wormholes in time travel. Thorne was one of the first people to conduct scientific research on whether the laws of physics permit space and time to be multiply connected. With Sung-Won Kim, Thorne identified a universal physical mechanism that may always prevent space-time from developing closed time-like curves. With Mike Morris and Ulvi Yurtsever he showed that traversable Lorentzian wormholes can exist in the structure of space-time only if they are threaded by quantum fields in quantum states that violate the average null energy condition. This has triggered research to explore the ability of quantum fields to possess such extended negative energy. Recent calculations by Thorne indicate that simple masses passing through traversable wormholes could never engender paradoxes. There are no initial conditions that lead to paradox once time travel is introduced. If his results can be generalized, they would suggest that none of the supposed paradoxes formulated in time travel stories can actually be formulated at a precise physical level. That is, that any situation in a time travel story turns out to permit many consistent solutions. relativistic stars, multipole moments and other endeavors with Anna Y.T. Cow. Thorne predicted the existence of red supergiant stars with neutron star cores. He laid the foundations for the theory of pulsations of relativistic stars and the gravitational radiation they emit. With James Hartle, Thorne derived from general relativity the laws of motion and precession of black holes and other relativistic bodies, including the influence of the coupling of their multipole moments to the spacetime curvature of nearby objects. Thorne has also theoretically predicted the existence of universally anti-gravitating exotic matter, the element needed to accelerate the expansion rate of the universe. Keep traversable wormhole stargates open and keep time-like geodesic free-float warp drives working. With Clifford Will and others of his students, he laid the foundations for the theoretical interpretation of experimental tests of relativistic theories of gravity, foundations on which Will and others then built. Thorne is currently interested in the origin of classical space and time from the quantum foam of quantum gravity theory. Publications. Thorne has written and edited books on topics in gravitational theory and high-energy astrophysics. In 1973, he co-authored the classic textbook Gravitation with Charles Misner and John Wheeler, from which most of the present generation of scientists have learned general relativity theory. In 1994, he published Black Holes and Time Warps, Einstein's Outrageous Legacy, a book for non-scientists for which he received numerous awards. This book has been published in 6 languages, and editions in Chinese, Italian, Czech, and Polish are in press. And in 2014, Thorne published The Science of Interstellar, in which he explains the science behind Christopher Nolan's film Interstellar. Nolan wrote the foreword to the book. Thorne's work has appeared in publications such as Scientific American, McGraw-Hill Yearbook of Science and Technology, and Collier's Encyclopedia, among others. Thorne has published more than 150 articles in scholarly journals, honors and awards. Thorne has been elected to the American Academy of Arts and Sciences, the National Academy of Sciences, the Russian Academy of Sciences, and the American Philosophical Society. He has been recognized by numerous awards including the American Institute of Physics Science Writing Award in Physics and Astronomy, the Phi Beta Kappa Science Writing Award, the American Physical Society's Lilienfeld Prize, the German Astronomical Society's Karl Schwarzschild Medal, the Robinson Prize in Cosmology from the University of Newcastle, England, the Albert Einstein Medal in 2009 from the Albert Einstein Society, Bern, Switzerland, the Sigma Xi, the Scientific Research Society's Commonwealth Awards for Science and Invention, and the California Science Center's California Scientist of the Year Award. He has been a Woodrow Wilson Fellow, Danforth Fellow, Guggenheim Fellow, and Fulbright Fellow. He has also received the honorary degree of Doctor of Humane Letters from Claremont Graduate University. He has been elected to hold Lawrence Chair for the year 2009 Leiden University, the Netherlands. Thorne has served on the International Committee on General Relativity and Gravitation, the Committee on US-USSR Cooperation in Physics, and the National Academy of Sciences Space Science Board, which has advised NASA and Congress on space science policy, adaptation and media. Thorne contributed ideas on wormhole travel to Carl Sagan for use in his novel Contact. Thorne and his friend, producer Linda Obst, also developed the concept for the Christopher Nolan film Interstellar. He also wrote a tie-in book, The Science of Interstellar. In Larry Niven's novel Rainbow Mars, the time travel technology used in the novel is based on the wormhole theories of Thorne, which in the context of the novel was when time travel first became possible, rather than just fantasy. As a result, any attempts to travel in time prior to Thorne's development of wormhole theory results in the time traveler entering a fantastic version of reality, rather than the actual past. In the film The Theory of Everything, Thorne was portrayed by actor Enzo Silentia. Partial bibliography. Thorne, S. In 300 Years of Gravitation. W. Hawking and W. Israel, 1987. Gravitational Radiation. Thorne, S. Price, H. and MacDonald, M. Black Holes, The Membrane Paradigm, 1986. Friedman, J. Morris, S. Novikov, D. Echeverria, F. Klinkhammer, G. Thorne, S. and Yurtsever, U. Physical Review D. 1990. Cauchy problem in spacetimes with closed time-like curves.